Okay, make it the chatterbox minimum. Thank you. So it's a cute little mnemonic, or a cute little word to remember which elements are diatomic. And the word is hofbrinkle. That's how it sounds. And from that, will tell us what. Thank you. That will tell us what elements are diatomic. H2, O2, F2, Br2, I2, N2, and here's the coal, Cl2. Now, notice something about these guys. Okay? So anytime you see these elements by themselves in a reaction, you know, something plus hydrogen, then the formula is H2, not just H. If you see oxygen plus oxygen, it's plus O2. If you see fluorine, it's plus F2. Bromine plus Br2. Iodine plus I2. Nitrogen plus N2. And chlorine, not chloride, chlorine. All right? What do you notice about these green ones? What's the deal with these guys? Same what? Same family. Oh, the same family. What's the family called? Okay. What's the family called? Halogens. For some reason, I don't know why, halogen particles are usually represented as in green. Nitrogen in model kits is usually blue, oxygen is red, and hydrogen is traditionally white. I don't know why. Someone invented that. Okay, carbon's black. Well, that's for obvious reasons, you know, burnt toast and all that. Okay? So as we saw before, and we can do simple particles with this, right? There's a couple different ways to represent this. Hydrogen wants to gain one electron. So two hydrogen atoms see each other and they say, well, I want to gain and you want to gain. So rather than trying to steal, we're going to form up a covalent bond and share that pair of electrons. Yes, sir?
Are those the only things that can do that?
Yes, these are the only elements that can do that. They're not the only things that can form molecular bonds, right? We can have other molecules, but these are the only elements. So when I'm talking about any element on the periodic table, all of the elements are atoms, right? Like our question, you know, well, what were our magnesium ribbon made of? What was magnesium atoms? It's not Mg2. Okay? Metals do a weird thing called metallic bonding where they like literally just kind of, they all sort of fuse together as one. It's sort of a freaky thing. You can look it up. It's an interesting thing. It's what makes them good conductors of electricity. But nitrogen, oxygen, fluorine, chlorine, bromine, iodine, okay? And handily, check it out. These are all gases too, except for bromine and, well, iodine's a solid. Iodine's a little weird. And hydrogen, obviously, off by itself there, okay? If we look at oxygen, oops. If we look at oxygen, it wants to form what we call a double bond. So it shares two pairs of electrons. Okay? Yep. I didn't put 7, I put 6.
Oh, why do you only put 7?
Oh, because it only has 6 electrons on the outside shell. If you look at the periodic table, the rings that we drew, remember, it's in the 6th column. 1, 2, forget these guys, 3, 4, 5, 6. So 6 electrons in the outside shell. I need to get 1, 2, and then I'm going to look like who? Neon. And then that means that I'm in the beachfront property there. Okay? You got it now?
Yeah.
Right. So the whole point of chemical reactions and electron bonding, transfer and sharing and all that, is so that elements cut a deal so that they all have a full shell. Okay? So they basically say to each other, it's better to share, right, than to just be lonely little, you know, needy little sucky hydrogen atoms and going, oh, I want one, and just be by myself, versus, hey, let's just share, cut a deal. You know, if you see someone else who you know, we'll be grown-ups about it and say, you know what, I'm more attracted to the oxygen. Well, actually, I am too, so that's why water forms. Okay? Interesting. Okay? Because this is what we did yesterday. We actually took that hydrogen gas and reacted it with oxygen. And we made water. If I went around and I popped it and I said, hey, do you notice the water now on the inside of the tube? And it's, yeah, look at that, it's condensed. So that's pure water. So imagine if our cars could be powered by hydrogen gas. What would our exhaust be? Distilled water. Not a problem. Why haven't we done that? Mind blown, right? Don't get me started about the evil oil empires, right? That's what we're fighting over here. Okay, so hofbrinkle. So F, I'll do that one in green just because it's fun. Fluorine has 1, 2, 3, 4, 5, 6, 7 electrons. And so does this fluorine. And so they're going to say, hey, let's share. Let's be F2 instead of just F by itself, fluorine by itself. Now we're F2. Okay? Hofbrinkle, Br. Okay? Br is also a halogen. It's following the exact same pattern as its cousin. You know, they're in the same family, so, and they share. Brinkle. Brinkle is I. So, gents, thanks. So iodine shares. Okay. Nitrogen. Now here's a weird one. Okay. How many electrons does nitrogen have in its outside shell? Raise your hand when you know. You should just know this. Look where it is in the periodic table, look on your periodic table, or look on the periodic table that you made. You should have at least one periodic table out. If not, it's ridiculous. And you're making life 10 times harder for yourself. Okay? And I shouldn't have to ask this. Yes, sir? 5, right? So it wants to do what? Yeah. What's a 1? Use 5 or gain 3?
What's gain 3?
Yeah, wants to gain 3. Okay? So, thank you. So this nitrogen atom wants to gain 3. So does that one. So what do? They share 3 pairs. Okay? So, high-tech word coming up. That forms what we call a triple bond.
So can you slow down a bit?
I sure can. Okay? So whenever we share pairs, we form a new particle called a molecule. Yes, sir?
Why don't any other elements do this?
Because A, they're not gaseous, B, they're metallic, right? And metals form under what's called metallic bonding. Like what's holding those magnesiums together, right? They're kind of fused-ish, okay? It's a phenomenon called metallic bonding. It's a whole other thing. We don't even really get into it, okay?
Yeah, so it only works with gases.
It just works with these elements, hofbrinkle elements. That's it. That's all you have to remember. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. That's it. So if you remember the word hofbrinkle, you'll be able to figure that out every time. Okay? Do you have to derive it like this every time? No. Just remember. Knowledge is power. I don't know if you can remember it. And our final atom is, our element is chlorine. And it is a halogen. So we're back to green. And share, thank you. So each chlorine atom has what we call 3 lone pairs and 1 shared pair. Okay? So, some of the ways that we can represent atoms as simple particles, right? So there is a chlorine atom, according to my simple particle. And there's a chlorine atom. Now, what are the charges on these atoms overall? Anything? What's the charge on an atom? 0 every time, right? Remember, atoms, A-T-O-M. No charge on an atom. If I share pairs of electrons, is there any charge? Has an electron moved? Have I lost or gained? overall, at the end of the day, I've not lost or gained. So molecules also don't have a charge. Okay? Because they're sharing. So how do I draw molecules? It's a thing called space fill. So you just clump them together as a unit without a charge inside of them. So that's a molecule. Okay? So they overlap. Does that make sense? So that's hofbrinkle.